and welcome back. In the first part of this chapter, we have studied the types of number, closure property, and commutativity property. Here we are going to study the other two. So let's go for associativity. What is that? Associate means joining the two things. If I'm joining the two things and I'm changing it, but still getting the same answer, then it is associativity. Okay, let's see one example. Suppose I'm talking for integers. This property can be with any types of number. So let's take two integers, that is 2 by 3, and then suppose 5 by 3. Now, adding these two, how much I get? By taking the LCM. To show associativity, I need third number. Suppose it is 1 by 3. I took all the denominator equal so that we can solve it easily. Even for different denominator, you can apply this property. So, I took the three integers, 2 by 3, 5 by 3, and 1 by 3. Suppose I'm doing it for addition, associativity for addition. So, here, suppose 2 by 3, 5 by 3, and 1 by 3. If I join two of them, and then third one. So first I need to add these two. That is LCM is 3. Then 2 plus 5 and plus 1 by 3. It will come 7 by 3. And then add 1 by 3, which is again LCM is 3. Then 7 plus 1, which is 8 by 3 is the answer. Now, let's associate some another two. Like here, I have associated first two. Now, associate the last two. So, in this case, it will be 2 by 3 plus 5 by 3 and then 1 by 3. Here, I'm associating the last two. Means the one in the bracket will get solved first according to the board mass. Denominator is same. So, it's a 5 plus 1. The answer will be 2 by 3 plus 6 by 3. And as again the denominator 3, it will be 2 plus 6, which is 8 by 3. Here we could have done the cutting also, like 3 ones are, 3 twos are. But it will be like 2 by 3 plus 2. To add them, again we need to take LCM. And that is the reason I did not do the cutting in the previous steps to make it easier. So as the answer is same, means what? Integers show associative property under addition. Now take one more example for the subtraction. We can take the same number. So here, if I take 2 by 3 minus 5 by 3 and minus 1 by 3. Let's associate the first two. We have studied associate for the addition. And let's learn the same thing for the subtraction, whether it is valid or not. So I have associated the first two numbers. So here the LCM is 3. Then 2 minus 5. What it will be? Minus 3 by 3. Then minus 1 by 3. See, 2 minus 5 is minus 3, right? Take the LCM 3 minus 1. The answer is minus 4 by 3. Correct? Okay. Let's associate the other two numbers. Here I have less space, but I'll try to write it neatly. So when I associate the last two, so I'll put bracket over here. Then 2 by 3 minus the LCM is 3. Then 5 minus 1. So what it will be? 2 by 3 minus 5 minus 1 is 4. 4 by 3. Then take LCM, 2 minus 4. 2 minus 4 is minus 2 by 3. See, the answer are not same. It means what? I will say integers do not show associative property under subtraction. Like that, you can try for addition, for multiplication and division. And we have studied this for integers. You can even try for other types of number. Natural number, whole number, then integers, then rational number. For all, you can try. So here they are discussing associative property for rational number, integers, whole number, and natural number. So we can try for all types of number by taking one example. Let's move from the bottom one because this is the simplest. Take any of the three natural number, 2, 3, and take 4 to make it simple. So it says associative. Natural number are associative under addition. We can check it out. How? Put the addition sign in between and associate 2. That is 5 plus 4, which is 9. Now the same number, but associating the last two. It is 2 plus 7, which is again 9. So as they are equal, yes, natural number are associative for addition. For subtraction, they themselves has given. Try for the multiplication. So take the same number. If I take 2 into 3 into 4, so multiply first 2, which is 6 into 4, which is 24. Now again the same thing. And this time take the last 2. So 2 into 12, which is 24. As the answer is same, I will say yes, the natural numbers show associative property for multiplication. You can try for division also. I'll show it here. So 2 divided by 3 divided by 4, associate these two. So division means it is fraction and then divided by 4. 2 divided by 3, as it is in division, in denominator nothing is there. So when I change the denominator into multiplication, the number get reversed. So 2 ones are 2 twos are. The answer is 1 ones are 1 and 3 twos are 6. 1 by 6. Let's try for another association. Here take these two. So according to board mass, the bracket will get solved first. So 3 divided by 4, which is 3 by 4. Now, as division getting converted into multiplication, so 4 by 3, 4 twos are 8 and then divided by 3. As this is not equal, no, it does not show associative property. So for whole number also yes, then it is no, then it is yes, and then it is no. For integers, we have seen this is yes, this is no, yes, then again no. Rational number also, the pattern will be same. Yes, no, yes, and then no. Let's move to distributive property. So here, to understand this, consider three rational numbers, all. Minus 3 by 4, 2 by 3, and minus 5 by 6. So write them 3 by 4, 2 by 3, and minus 5 by 6. Now distributive means we are studying distribution of multiplication over addition. Distribution of multiplication over addition. What does it mean? It means suppose there are three numbers A, B, and C. Here it is multiplication and in bracket there is addition. So distribution of a number which is in multiplication and over the addition. So how to write? Here I'll put multiplication, then bracket, and here it is addition. So what will happen? Like that, if a pizza has come to your home, this is a pizza and you are two siblings. Means what? If pizza has come, so it has to be distributed among all the siblings or all the members of the house. Same way, we can write 3 by 4 into 2 by 3 means given to a member. Then there is a minus and there is a plus. So that will also get multiplied. And we know minus plus is minus. So it is 3 by 4 into minus 5 by 6. What will happen if some number is getting cut? Do that. That is 2 ones are, 2 twos are, 3 ones are, 3 ones are. In numerator, only 1 is left. So minus 1, then 2. Here, 3 ones are, 3 twos are. This minus and here will give you plus 5 upon 8. Taking the LCM, 2 and 8, we got 8. If you don't know the how to find the LCM, comment me. I'll definitely reply. So 2 and 4 is 8 and making the denominator equal. So 4 ones are 4 and then 8 is already there. So to equate it, I just multiply by 5. So minus 4 plus 1 is 1 by 8. So this is the distributive property. We do not study for individual number. Here, in place of rational number, you can take any types of number. But the distributive property means distribution always happen either for the plus or for the minus. Okay, let's study two more things which is very important over here. That is role of 1 and role of 0. What it is? It means if I add any of the number, any types of number with 0. Suppose I'm taking 5 plus 0. We know it is 5. Means an addition, 0 does not play any role. Or even if I subtract 0 from any of the number, it does not affect. But subtracting from the 0 definitely will affect. What does it mean? Subtracting from the 0 means 0 minus 6, which is minus 6. Correct? So we are talking about addition or subtraction of 0 from any number does not affect it. But talk about multiplication. In multiplication, if I multiply any of the number with 0, it is 0. If I divide any of the number with 0, what it is? It is not defined. Not defined. Or we say it infinity. So you cannot divide any number by 0. Let's take the role of 1. If you multiply or divide any number by 1, suppose I'm taking 2 by 3, multiplied by 1 is what? Nothing but 2 by 3. If I take 2 by 5 and divide by 1, what it is? Nothing but 2 by 5. Means multiplying by 1 or dividing by 1 does not affect the number. So here in short, I say additive identity is 0 and multiplicative identity is 1. Additive identity is 0 and multiplicative identity is 1. So let's start with the exercise. Exercise 1.1 first sum. It says, name the property under multiplication used in each of the following. So I can see minus 4 by 5 multiplied by 1. And then 1 multiplied by minus 4 by 4 is minus 4 by 4. So definitely multiplying 1 is what it is. Multiplicative identity. What it is? Multiplicative identity. So here you can write that. In the second case, can you see minus 13 by 17 and multiplied by minus 2 by 7. And they have reversed the number. Reverse the number means what? We have studied which property? It is, yes, commutative property. Commutative property. Commute means we have studied it is move. To move. Communication, commutative. So as the number has just inverse, it is commutative property. And for which number? As they are rational number, we will say commutative property for rational number. Here, can you see a number and they have reversed the numbers. It is known as multiplicative inverse. What it is? Multiplicative inverse. That I forgot to teach you, so I'll teach it here. So if you have any of the number, any number, suppose it is in the form of A by B. And if you reverse this number, that is B by A and multiplied by these two, you will always get 1. That is multiplicative inverse. Second question says, tell what property allows you to compute this. So here I can see it is in multiplication. And here 1 by 3 in first case here to here is outside and the last two number I have multiplied. But in the second case, I have taken the two number together, then the third one. It means it is what? It is associative property. How associative? Because associative means join. So I'm joining the two number. And if you want to calculate it, you can calculate any of these number. Like here, 3 ones are 3 twos are, which is 2, and then 4 by 3. And here you will get 2 fours are 8 and by 3. That is about this. Let's move to the third question. So the third question says, the product of two rational number is always a, you can try, take any two rational number, 2 by 3 and suppose 5 by 6. So you can do the cutting or whatever. After solving it, what you are getting? 5 by 9, which is a rational number, correct? So can I say the product of two rational number is always a rational number? Suppose I have 5 by 3 and 9 by 2. Here I can do the cutting. 2 ones are 2 twos are, 3 ones are 3 threes are, which is 3 twos are 6. But 6 is a whole number, correct? But here just notice a thing. Whole number is also a rational number, correct? So it means whatever you are getting, it is nothing but the product of two rational number is always I can write rational number, correct? With this, we have completed the chapter. If you want some extra question or summary of the chapter, please do comment me. I will definitely answer. And for online classes, you can mail me. Thank you. Happy study.